Okay, today we're looking at section 10.1, which is the Pythagorean theorem and its converse. And hopefully by the end of this, you can say that I can use the Pythagorean theorem to find the missing side of a right triangle and its converse to identify right triangles. So first of all, what is the Pythagorean theorem? The Pythagorean theorem states in any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So in other words, if we're looking at this diagram here, the lengths of the legs are A and B. So if I took A squared plus B squared, so this length squared, is equal to C squared, which is my hypotenuse. This is known as the hypotenuse. We have two legs and we have hypotenuse. So it literally means if we squared them, and we made a square out of it, made a square out of this side over here, B, and if we looked at the areas, the sum of those two areas would be equal to the sum of the area of this square C. So that's the Pythagorean theorem. So how can I prove that that is true? That might be something that some of you are asking. If I were to look at this square, hopefully we can see a large square and then a smaller square with triangles inside. So if I looked at the large square, the length of the sides is A plus B. If I tried to find the area of this square, you could say that I could take A plus B times an A plus B. So if I use the FOIL to work through that, I would have A squared plus AB plus AB plus B squared, which simplifies to A squared plus 2AB plus B squared. Okay, so we know that that must be equal to the area of the smaller triangles inside and the smaller square. So the smaller square is A squared. If you think about the formula for the area of a right or area of a triangle, it's 1/2 base times height. So if you look at all these triangles, we got a base of B, use a different color, a base of B, height of A. So if I said I'm going to have 1/2 the base, which is B, times the height, which is A, and I looked at that as the area of one of those triangles, and I looked at how many I had, I really have 4 of them. So if I took this times 4, that would simplify to 2, and if I rewrote the A and the B around, so I'd have 2AB, we know that that has to be equal to the area of the, or excuse me, not equal to, but if I added on the area of the smaller square, this square right here, we know the area of that square is going to be C squared. We would know that these two things have to be equal. So if I said A squared plus 2AB plus B squared equals 2AB plus C squared, we can then identify that these two things are the same, so they would really cancel each other out. So what I'm left with is the formula A squared plus B squared equals C squared. Okay. So now that we have an idea of what it is and the background on it, how are we going to apply it today? Well, we're going to use that idea, this A squared plus B squared equals C squared, to find the missing side lengths. So for instance, on the first one, if I know the A is 16, the B is, or excuse me, A is 16, B is 12, how could I find the hypotenuse, or C? So it would be 16 squared plus 12 squared equals C squared. So 16 squared, if I looked at that, 16 squared is 196. Sorry, 256. 256 plus 144 is equal to C squared. So 256 plus 144, that's 400, is equal to C squared. So to figure out what C is, we simply take the square root of both sides. So that would tell me that C must be equal to 20. Okay, so if I did it on this next one, so now I know that A is 15, so I'd have 15 squared plus B squared equals 20 squared. So 15 is squared is 225. 20 squared is 400. So if I subtract the 225, I would get b squared is equal to 175. Okay, and then if I took the square root of that, I would then have to simplify the square root of 175 because I want to write it in simplified radical form. So what's the biggest perfect square that goes into 175? Well, I know 25 goes in there 7 times. So what would this simplify to? 5 root 7. That would be the length of b. Okay, so let's look at for this next one. In fact, you try it on this next one. Pause the video, try it, come back and see if you got the right answer. Okay, so you should have set it up as this. A squared plus 18 squared equals 30 squared. So I got a squared plus 18 squared should have given you 324. And 300 squared is 900. And if you subtract the 324 off of there, you get a squared is equal to 576. Now, if you remember, 576 does happen to be a perfect square. So a must be equal to 24 after you take the square root of that. A would be equal to 24. Okay, and now for the last one, a squared, so 72 squared plus b squared has to be equal to 98 squared. So 72 squared, it's 5,184 plus b squared is equal to 98 squared, which is 9,604. If I subtract off the 5,184, I would get b squared is equal to 4,420. And I'm just checking to see if that's a perfect square. That is not a perfect square, so then we have to look for the perfect squares inside of that. So if I try and break down square root of 4,420. I know that 4 goes in there, so I'm not going to find the biggest one right away. So I'm just going to divide by 4. I know 4 goes in there. So if I divide it all by 4, 4,420 divided by 4, I get 1,105. So if I check some other perfect squares in there, I'm not finding any right now, so I'm just going to put 2 square root of 1,105. Now I should go back and check some more, but I don't have the time right now. So you just have to double check to see if you have any other perfect squares in there. And then if not, then we'd have that simplified. Okay, now the converse of it. Converse states if in a triangle a squared plus b squared is equal to c squared, then it is a right triangle. So what we're trying to do now is determine if it's a right triangle. So a and b have to be the shorter two sides. So we want to know, is 15 squared plus 20 squared, is that equal to 25 squared? Okay, so 15 squared is 225. 20 squared is 400. 25 squared is 625. So is this a true statement? And the answer is yes, so we'd say that this is a right triangle. Okay, if I look at the next one, is 22 squared plus 24 squared, is that equal to 30 squared? So 22 squared is 484. 24 squared is 576. If you add those two together, do you get 900? And the answer would be no. So it's not a square or not a right triangle. Okay, so you test the next two, see if it's true or not. So you should have taken 32 or 38 squared and gotten 1,444. You should have gotten 72 squared, which is 5,184. If you add those two together, you get 6,628. And is that equal to 80 squared? And the answer would be no. 80 squared is 6,400, so it's not a right triangle. Okay, so now this last one. 46.5 squared plus 62 squared, does that equal 77.5 squared? Okay, so 46.5 squared is 2,162.5, or 25, excuse me. 62 squared, 3,844. And if we add those two together, you should get 6,006.25. And is that the same thing as 77.5 squared? And the answer is yes, you do get the same thing. So this would be a right triangle. So hopefully this is making sense to you. If not, make sure you come with your questions tomorrow. Okay, and that is a wrap.